Hello everyone. So next we are going to see some of the examples of the third model. So here in this case the following code will continuously send out to port 0 alternating the value 55 and AAH, right? So by default we know like for all the ports for 8051 as you can see port 0, port 1, port 2, port 3. So all these 4 ports will be used as a default output port, but if you want to use them as an input port you need to send a 1 value to that particular port. So here in this case A is loaded with the 55H, so 55H in the sense 0101 and this 0101 and that particular value 5 in the sense it's a 0101 0101. So this 01010101 value we are going to send to the port 0. So this port is alternately making all its pin alternately on and off. So 0 in the sense it's going to be by default it is going to be an output port. 1 in the sense it is going to be input port. So you are going, if you are sending 0 in the sense it will be output port, and 1 in the sense it is input port. So by default what you are making is you are making it as first pin as an output, next pin as an input, next pin as an output, next pin as an input. Like this alternately you are making output and input. So then you are calling a delay. So a call delay. So you can know you are aware of this thing. A call delay in the sense is absolute call. So you are going to call a delay program. So this is going to introduce a delay between these two instructions. That is the instruction move P0, A and A, 0 AAH. So between these two instructions you are introducing a delay. After that as it is been given in the description 55 and AAH you need to send it. So again I need to load the accumulator with the 0 AAH. 0 AAH in the sense we know it's a 1010. Earlier it was 0101, now it is 1010. So whatever earlier ports earlier port pins which are as used as an input, they will be made as an output here, and those who have made as an input made with here they have made as an output. So we are going to just interchange the pins with the input to output. Then you are going to make move P0, A. So here accumulator's content will be loaded to P0. So you are going to make these accumulator these port 0 pins as input and output alternatively. So again you are going to call the delay and you are going to execute this program continuously using the sjump back, right? So this is a short jump you are using, and this is going to jump back to here, and this continuously this program is going to be maintained in a loop. So next we are going to see some of the other programs. So here in this case port 0 is, as it is been given in the description, port 0 is configured first as an input port by writing ones to it, and then the data is received from the port and sent to P1. So here in this case what they have made is accumulator is loaded to 0 FFH, then that total data will be loaded to P0. So P0 you are going to configure as an input port. So we know like 00 you are sending in to the port 0 in the sense you are going to make as an output. If you are sending FFH in the sense you are going to make this as an input, right? So that move A, P0. So whatever the since this P0 is configured as an input port, so what from this P0 port 0 whatever the input data we are getting through this port 0, that we are going to load it to accumulator. Then again accumulator data whatever obtained from here, that will be loaded to port 1, right? So there will be a question like why we are not making this P1 as an output port. So since the by default P1 the ports will be as an output port only, so no need to configure as an output separately. So again here this accumulated data is moved to the port 1, so it is an output port. So here all the data which is obtained from port 0 is the input is given back to the output ports, and again it is going to be maintained in a loop. So you can see here it's a jump back, short jump it is going to be given, and it is going to be in a loop, right? So here it is going to be maintained in a loop, right? So we are going to see some of the other examples, right? So in the next example we can see port 1 is configured first as an input port by writing ones to it, then data is received from the port and saved in R7 and R5. So what they are doing is they are taking some values from the port 1, and that value you need to load it on the R7 and R5 registers. So we are going to see how it will be done. So move a comma ffh. So here move a comma 0 ffh, in the sense you are going to have 0 ffh value into the accumulator. Then that content will be moved to the P1, in the sense P1 is configured as an input port. So now move a comma P1. So whatever since this has been configured as an input port, whatever the data it is getting from the input devices connected externally, that data will be taken to the accumulator. So if suppose some data is we are getting through this P1 port, that will be loaded to the accumulator. And since P1 is an 8-bit, so 8-bit data we are going to obtain to the accumulator, and that 8-bit data we are going to transfer to the R7 register. Then we are going to maintain a call delay here. So that is we are going to give a delay between these two instructions, that is move R7 comma A and move A comma P1. In the sense, whatever the first data we are obtaining from the port 1 and the second data we are obtaining from port 1, we are in between them we are giving certain delay, right? So this is how it is going to be done. So next you can see like move a comma P1, in the sense port 1's second data whatever you are obtaining, that will be loaded to accumulator, and in turn it is loaded from accumulator to R5 register. So that's what it is been mentioned in the description, right? So we know regarding this call delay, how it's work, absolute call delay. So once this has been called, the program counter is going to load with the delay, the address of the delay program, right? So this is a subroutine or sub call sub functions where the delay program is written, and the program counter is taken to that particular location, and it is going to execute the delay program. And once RET instruction is executed in the delay program, then it is going to return back to this. And before this would this would taken from here to the subroutine program, what it does is it is going to save the next instruction, means this move a comma P1 address will be loaded to the stack memory, and once it is been executed, again it is going to retrieve that address from the stack memory, and again it is going to execute from here only, and all the instruction further it is going to execute. So this is how this program is going to work. It's going to take some data from the input port, and it's going to load to the R7 and R5 registers respectively. So next we are going to see some more programs. So in this program you can see like it is particularly mentioned for certain amount of the delay. So as it is been given here, they have not mentioned how much of the delay it has to be maintained between the first data and second data. But here in this case, in the second example, as you can see, they have mentioned the time delay between the tasks. So we need to particularly maintain this delay. So we are going to see what actually this program is going to do. Write a program for the DS89C420 to toggle all the bits of P0, P1 and P2 every 1/4 of a second. In the sense, it's a 0.25 second we need to maintain the delay. So this is a DS89C420, in the sense it's a variant of a microcontroller. So this is nothing but a microcontroller. So what they are telling you is you need to toggle the bits of this port 0, port 1 and port 2, and the toggling delay interval need to have this much of the time, that is 0.25 seconds. So before I would start with this program, let me take you to the delay program first, how actually it is working. So here they have mentioned as what is the amount of the delay they have to maintain. So as they have given, like you have to maintain 0.25 seconds of the delay. So 0.25 seconds is our main motto. Then in this case, in this delay program, main aim is to calculate these count values, right? So, and one more thing is like when you are using the decrement jump no 0 instruction, it uses some 4 machine cycle, and for this microcontroller we will be using 11.0592 megahertz clock frequency. That 11.0592 megahertz clock frequency will generate you the time period of 90 nanoseconds. So this is the time period obtained from the clock frequency of the microcontroller, right? So these two are the things which are known for us. So this part we need to calculate. So how we are going to calculate, in the sense, this is the total time required from this delay program. So that thing we know. So 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 if you just calculate, it's going to be 0.25 seconds. So 0.25 is the known thing, then divided by 4, then divide by 4 and divide by 90 nanoseconds. So it is going to give you this total count, right? So this is how it is going to retain the delay for this program. So if you can retain this whole delay in one register, that is also okay. So this is how we can decide the time delay, how we are going to write the time delay program for our particular program given, right? So this is how we are going to generate the 0.25 seconds. So if it is 0.5 seconds, what we need to do is we need to increase this count value. So this is the count value. So since they are using the 3 registers, they have kept 11, 248, 255 like this. So it is not particularly we need to keep the like this only. So it is the value which will give you this 2.5 seconds, right? So 0.25 seconds. 0.25 seconds is the aim what we need to get. So the decrement jump to 0 will give 4 machine cycle it uses. Then 90 nanoseconds is the total time what you can say is which is obtained from the clock frequency. Then so this is total, it is going to give you the 0.25 seconds, right? Okay, so in case if you are having 0.5 seconds delay, so what we need to do is we just have to increase these values. Okay, so your ultimate value you need to have is 0.5 seconds. Then this thing is known, that is 4 machine cycle is known, then 99 nanoseconds is known. So we just have to divide by 0.5 seconds divided by 90 nanoseconds, and whatever the value obtained divided by 4. So whatever the count it will be obtained, so that will be the total count. You need to divide it here, means so whatever the value you are obtaining, suppose you are having some 388, so 388 is the value. So you need to take these values x, y, z, these values you need to take such that multiplication of these 3 values will be 388, right? So likewise you need to choose the value. So we are going to see how actually this program is going to be done. So org 0, so origination from the 0, then move a 55h, accumulator is loaded with 55h, move p0 a. So accumulator is some of the pins are going to be port 0, some of the pins are made input and some of the pins are made output. Similarly here for port 1 and port 2, so port 0, port 1, port 2 are loaded with the initialized with the 55. Then called QS delay, so quarter second delay. QS delay in the sense quarter second delay, they have named it as. So you can name anything, so it is not particularly you need to give as an QS delay. So you can give any name, so you can just give as an QS also, no problem. So you need to write as an QS, right? So call QS delay. Then when you call this, it is going to take you to this. So we know how the process will happen once you call this one, call QS delay. So next instruction, this one, next instruction's address is loaded to stack memory. Then this address of the new this subroutine or this delay program, it will be taken and it is going to be executed. So once this execute the RAT instruction, again it is be retrieving these means it is going to take you to this instruction, that is by retrieving the address from the stack memory, it is going to take you from this instruction to the further. Then next instruction is what? Move a 0 ah, then move p0 a, move p1 a, move p2 a. Means initially we have initialized with some of the pins as an input and some of the pins as output, and after some delay those pins are output, they will be made input, and those pins are input, they will be made output. Likewise it will be changed. 55 is just inverse of the AAH. So this is how it is going to be done. Then called QS delay in the sense, again it is going to execute this delay program. So before this means after this 55H sending value and after this 0AH sending value, we are going to call this delay program and we are going to execute it. So this calling of the delay program is totally based upon how the description is given. So sometimes they will ask you to give the delay between these two only, so no need to write the delay for this one, delay here. Okay, so it is based upon how they are asking. So sometimes if they ask the delay between initialization of port 0 and port 1, so that time what you need to do is you need to insert a called QS delay here, right? That is after the move p0 comma a. After that you need to insert a call QS delay, then we need to write move p1 comma a, then again that call QS display, then again move p2 comma a. Like that you need to insert the QS delay. So it is based upon the description, problem definition, how it is been given. So based upon that all the things are going to change. And again based upon what kind of the controller you are using, these things are going to be changed. So since we are using the microcontroller 11.059 megahertz frequency, we will be using this 90 nanoseconds are going to be fixed, and since we are using decrement jump no zero instruction, 4 machine cycles are fixed. So this part is fixed, and these are going to be variable. So this variable part you need to calculate, and this calculation is become based upon what will be the AND value you need to obtain, right? So if they want 1 second, based upon that thing you need to calculate this xy. This is just like x, y, z. Based upon that you need to keep these values, and you need to have delay generated. So next we are going to see some of the other programs. So in this we are going to generate the 50% duty cycle. So write the following program to create a square wave of 50% duty cycle. Write the following program, create a square wave of 50% duty cycle on bit 0 of port 1. So here in this case 50% duty cycle, in the sense this is the on and off period, both are same. So we are going to see how it is will be done. The 50% duty cycle means that on and off state, that is high and low portions of the pulse will be going to be same, right? So that's what we know. Then therefore we toggle p1.0, which is time delay in between each state. Means whatever the time delay we are keeping, that time delay it has to be kept between the two instructions. So first instruction is set b p1.0. Set b p1.0 in the sense it is going to set the bit, that is which bit it is going to set. So p1.0, port 1's 0th bit it is going to set, right? So it is going to be port 1 we are port 1 0th bit we are reading, and that will be set to high. In the sense it is going to make this as a input port. Then a call delay, so there is a delay between this instruction. Then again clear p1.0. So continuously we are giving a call delay, sorry, L call delay between p1.0 set and p1.0 clear. So this is how it is going to, this is how it is going to give a delay in between set B and clear B. In the sense set in the sense it's high pulse, so this is high pulse. So clear in the sense it's low pulse. So in between this one we are giving the delay. So this is how it is going to generate the high and low pulse alternatively. And S jump here in the sense is going to repeat it continuously, so that you can generate the high that is waveform with a 50% duty cycle, square wave with a 50% duty cycle continuously. So this is how it's going to be done. So there is an alternate wave it's been given, like CPL in the sense complement bit. So you are going to just complement p1.0. So it is going to be complemented the p1.0 continuously, and it's going to be called L call delay. L call delay in the sense long call you are going to call, you are going to call this delay. Then it is going to be alternatively making 1 and 0, and S jump here in the sense it's going to be continuously in the loop, right? So this is how it's going to work. So next we are going to see some of the other example. Right. So in this case, as it has been given in the description, write a program to perform the following. Keep monitoring the p1.2 bit until it becomes high. When p1.2 becomes high, write value 45H to port 0, send high to low, pulse to p2.3. So here in this case you need to observe the p1.2 bit. Then if it is high, then you need to send the 45H to port 0 and send high to low pulse to P2.3. So these are the three tasks you need to perform. So as it is been given in the first, set B P1.2. Set B P1.2 in the sense you are going to make this P1.2 as an input port. Then move A 45H. So accumulator load is loaded with a 45H. Why it is loaded with a 45H in the sense, in the second case they are told like you need to send 45H value to P1.2 when it is high. That is, we need to send the 45H to port 0 when P1.2 is high. So where we are going to use this 45H. Then next instruction JNB P1.2 comma again. So it is going to check the bit of the P1.2. So it is going to jump not bit. So in the sense, if the P1.2 is not 0, it is going to be in this loop. So whenever it becomes high, then it will be going to for the next instruction. So that is what it is in the first. What they are told, keep monitoring P1.2 bit until it becomes high. So in this loop, that is in this instruction, they are checking whether the P1.2 is high or low. So if it is high, then it will be going for the next instruction. If it is low, then it will be in the same loop. That's JNB P1.2 again, in the sense it will be retained in the same loop when it is 0. When it is 1, then it is going to take you to the next instruction. Right, so we know regarding this JNB in the sense jump not bit. Right, so accumulator is loaded with the, so second condition is what, when P1.2 becomes high. So when it is 0, it will be in the loop. When it is 1, it is going to come to the next instruction. Then what they are told, write a value 45 to port 0. So accumulator content is 45, that will be loaded to the port 0. Right, so this is how it is going to be done. Then third condition is what, send high to low pulse to P2.3. So to make P2.3 high, we need to use the instruction set B, and to make P2.3 as 0, we need to use the instruction clear. Right, so set B and the clear to is the two instruction which will be used to set and clear the bits of this P2.3 or P2.3 port. Right, so next we are going to see next example. So in this case, assume that bit P2.3 is an input and represent a condition of an O1. If it goes high, it means that the O1 is hot. Monitor the bit continuously. Whenever it goes high, send high to low pulse to the port P1.5 to turn on a buzzer. So this is a real-time example. It's been given like you need to assume as an O1, and you just have to continuously monitor, and whenever it goes high, then you need to send high to low pulse to P1.5 and it will turn on the buzzer. So we are going to see how it will be working. So this is the program, it's been written. So jump not bit P2.3 here. So it is going to check continuously JNB P2.3 comma here. So it is going to check continuously whether the P2.3 is high or low. When it is low, then it will be continuously kept in this loop. Then it is high, then it will be taken to next. So that's what the condition is given. Assume the bit P2.3 is an input and represent the condition of an O1. So P2.3 is representing the condition of O1. Then if it goes high, it means that O1 is hot. So if it goes high, means it is, if it comes out of this loop, means it is as if the O1 is hot. Then monitor the bit continuously. Whenever it goes high, send a high to low pulse to a port P1.5. So whenever it is high, means whenever it is hot, one is hot, that time we need to send P1.5 high to low pulse. So how it will be sent, we know, set B P1.5 clear P1.5. So it will be sending high pulse and it will be sending low pulse. So indirectly it is making a buzzer, and it is going to give the indication that the particular one is hot. Right, so these are some of the examples. So few more examples we are going to discuss in next.